All right. So we are talking, we've just done a quick review just a few minutes ago about solving linear systems. That's another word. There's different ways you're going to hear this. You're going to hear systems of equations, okay, which is the one I usually use when I talk about them. You might see the word linear systems. Linear means straight line. And system means more than one, right? Right? So it's going to be where the two intersect. Linear systems. Systems of equations, linear systems, same thing. Sometimes you'll see them called simultaneous equations. There are two equations simultaneously exactly at the same time on this same graph. Big deal, right? And you just want to know where the point is that they intersect, right? So those are different ways you'll see it. And I have told you something in the past. I said if there is one variable and one equation, you can always solve for that variable, right? X plus 4 equals 10. You can always solve for x. You just subtract 4, right? And then you get x is equal to 6. Easy, right? But if there are two variables and one equation, I can never solve for that. I have not a clue what y and x is. Not a clue. I could take a guess, and maybe on my millionth try I'd be right? And that's what the lottery is. It's just a bunch of guesses, right? We don't know what it's going to be until they pull it out of the drawing, right? So same thing for here. I don't know what x and y are. But if there are two unknowns and two equations, I can suddenly solve for both variables. Do you really believe that? Should I put up an easy one to show you? Okay, I'll give a second equation that'll show you.
Are you filming this right now, Gary?
I am filming this.
Yeah, okay.
I am filming this. All right. Is that an equation?
No.
That's the answer.
It's not a very hard one, is it? But it is an equation. There's an equal sign, right?
Yeah.
It says y equals 11. Y is the same thing as 11. So how would I solve for x? I already know what my y is now, suddenly, don't
11.
I? Oh my god, I don't even have to solve for y. They gave it to me. Oh my gosh. So now I can just plug that in. I could substitute. Ooh. I could substitute this. Since y is the same thing as 11, I could substitute this in for this y right there. Does that make sense? So let's just try it. We got 11 equals 3x plus 2. Can I do this?
Yeah.
How would I solve it? I want to know what x is. That's my only unknown now. I know my y, I need my x.
Subtract 2.
Subtract 2, subtract 2, subtract 2. I've got 9 is equal to 3x. Now what do I do? Divide by 3. What do I have?
3.
X is equal to 3, right? So I know that my solution, my point where they both intersect, is at 3, 11. That's the point of interception. That's the solution to this linear system, right? Pretty straightforward? Yes, question?
How did you get the 11? Because there's a y.
It was given. This is an equation. If I gave you these two equations, right, then you would have to say, oh, well, wait, y is equal to 11. It's the same thing as 11. So I'm going to move this 11 up to this y here.
Oh.
See what I'm saying? Because really, think about it. Since I'm looking for a point that works, that's part of both equations, right? That point where they both intersect, that point is on this equation, and it's on this equation, right? So the y's are always going to be the same for that point, and the x's are always going to be the same for that point. Therefore, I can make this y's value equal to this y. Does that make sense?
Yes.
So I'm just putting this, substituting this 11 in for this y. And then suddenly I get x equals 3. So my point is x comma y, 3 comma 11, 3 comma 11, right? So that's pretty straightforward. But they're not usually that easy, okay? Usually they make the equation just a little harder. So can I try another one now? A little harder? Okay. Can I erase?
Yes.
Okay. We're going to still use the same first equation. But I'm going to write a different equation for the second equation. This one I do. Okay. So x plus 2y equals 11. X plus 2y equals 11. Whoops. Equals 11. All right. I think we're going to do a quick review of types of equations. Okay? Remember I told you there's 3 useful ways to write equations?
Yeah.
There's a million ways to write equations, but there's 3 useful ways, right?
Yeah.
And the 3 useful ways are point slope. Well, wait a minute. Slope intercept, sorry. Always start with that one because that's the most. That's y is equal to mx plus b. Point slope is the next one. This one is y minus y1 is equal to m times x minus x1, right? Remember that? And then the last one is standard form, where the x's and y's are on the same side of the equal sign. Notice the y's are on the left here, the x's are on the right. Y on the left, x on the right. But the standard form would be ax plus by equals c. An example would be 2x plus 3y equals 12. Okay? All right. Given that information, what is the first equation written in? What form?
Slope intercept.
Slope intercept, correct. It gave me a slope, 3 over 1, and a y-intercept, 2. What is the second equation written in?
Standard.
Standard. I have my x's and my y's on the same side. I don't know how to memorize that, but that's the way it is. X's and y's stand together. That's it. Stand together, right? Togetherness, right? They standard. It's the standard of standing together. Okay, so that's it. All right, so now it doesn't matter when I'm using substitution. I actually, let me back up for 1 second. I just want to say one thing. We have learned that graphing is not very easy to do, to always solve a problem, because sometimes the problem is in the middle somewhere, right? And your answer would be a fraction or something, and we don't know what that is. So algebraically, it's a much more accurate way to solve systems of equations. So I'm going to be teaching you 2 methods to solve them algebraically. Today, the first method is solving systems by substitution. So when you solve by substitution, you find an equation that says y equals or x equals. So this is important. One equation must say y equals or x equals. Okay? It's got to say y equals or x equals. Very important. Which equation of the 2 equations I gave you starts that way?
The y-intercept.
Yeah, the very first one, right? This says y equals. There it is. Y equals. Got to be y equals or x equals. It starts with y equals. Could we use this one? No.
No.
Because it's x. Doesn't say x equals. It says x plus 2y equals. Too much stuff. You know what I mean? So what I do, okay, so that's the first thing, right? That's really important. So that's step number 1. Just have to check that. Step number 2, circle what y equals or x equals. All right, I'm going to circle this. I'm going to use a different color. I'm going to circle this. All right, you with me?
Yes.
Does everybody agree with me that y is exactly the same thing as 3x plus 2? It's It's exactly the same thing, right? Yes? 3x plus 2 and y, they're the same thing. Because it says so. Y is equal to 3x plus 2. Therefore, I can replace this y here with 3x plus 2. You with me?
Yes.
All right, so what I'm going to do is I'm going to rewrite the second equation with, instead of a y, I'm going to put 3x plus 2. So here we go. We're going to do it over here. X plus 2 parenthesis 3x plus 2 parenthesis equals 11. You guys see how I got that? You see that? Are you writing this down? Your notes. What? Oh, sorry, I didn't tell you when to start. Yeah, but now the lecture started, so you have to write it down. Yeah, this part is important to do this. Does everybody see how I got that? It was really easy. I just substituted this in for y, because that equals y. So I just substitute in. Now, what property I'm going to have to use to solve this? Distributive. Do I have only one kind of variable?
No.
Only x's, right? So it's going to be a piece of cake. So I'm going to use my distributive property. Boom. So we got x plus 2 times 3x. 6x plus 2 times 2 is 4 equals 11. Now what do I do?
Subtract 4 from both sides.
Okay, subtract 4 from both sides. What do I have?
X plus 6.
Well, what is x plus 6x?
7.
7x.
Right? Isn't that says I have 6 x's, and I'm adding, I've got one more x.
Oh.
So it's 7 x's, right? X plus 6x is 7x equals, what's 11 minus 4?
7.
7. Okay, now what do I do?
Divide by 7.
Divide by 7, divide by 7, divide by 7. X is equal to 1. All right, there's my first number. I know my x. But what do I have to know also? I have to know my y, because I need to, x only tells me which way to go, left or right, on a graph. It doesn't tell me how far to go up or down. I still need to know my final destination, right? I just know I'm supposed to go over 1 to the right, but I don't know whether I go up or down yet. So I have to find out what y is. What can I do? Okay, wait, let me just add this. Substitute the circled expression, right? Substitute circled expression in appropriate place, right? And then solve for one unknown. This is kind of making it harder, to be honest with you, but 5. Now, so this is where we've gotten so far. Now 5, we have to take this number and we have to plug one in for x in either of these two equations, right? What am I trying to solve for? Y. So which of these is already set up for solving for y? Which one? The top one. Why?
Because it's y equals.
Y equals. That's what you're trying to find out. What does y equal, right? It's already there. Now, it would work fine if you use this one too. It would just be more algebra. You'd have to move things around, right? You know, because you'd have to get the x and move it over here, and and then you'd have to divide everything by 2 to find y. Here, it already is y is equal to this, so it just tells me what to do really fast. So I just plug it into this one. Y is equal to 3 times 1, because my x is 1 now, plus 2. So I have y is equal to 3 plus 2, y is equal to 5. So I can either have my answer like this, where I put a box around my x equals and my y equals, or I can say that the solution is 1, 5. Because my x is 1 and my y is 5. Right? And that would be my answer. Okay, is that clear?
Yes.
So all we had to do was just, so the last part was solve for unknown, substitute into original equation to solve for other unknown. Okay. So how are we doing? Oh God, the class is almost over.
We have a minute left.
All right, is it clear?
Yes.
So first thing, you make sure it says y equals or x equals. You find the one, sometimes they both say that, so just circle one of them, right? Just circle one of the y's, right? And plug it in for the other y, right? But if only one of them does, just circle that one, plug it into this, solve for the x in this case, right? Then once you find x, plug it back into one of these two equations to solve for y. And then you're done. It's really easy. It's really easy. So
Any homework?
homework is right here.
It's right there.
So I'm going to turn this up.